Angle between two intersecting straight lines. Right, angle between two intersecting straight lines. Right, so when angles meet, there's always an angle that's created. We know that. So we want to find this angle now, right? We want to find the value of this angle. We want to measure this angle now. So how are you going to measure this angle? Right, whenever two lines meet. Oh shit. Here is so if these are two lines, right? This is line L1 and this is L2. Whenever two lines meet, there's an angle. I mean, there are angles. So there is this and there is this. We want to find this angle, right? The degree of this angle. Now, how do we find it? So this section will take us through that. In general, the angle theta between two lines with gradient m1 and m2 is given by, right? Is given by tan theta is equal to m1 minus m2 all over 1 plus m1 m2, where m1 is greater than m2. Perfect. So that's what we are going to use in this section, and then we have to memorize this formula. So when two lines meet and then we want to find the angle between these two lines, the formula is given by tan theta is equal to m1 minus m2 divided by 1 plus m1 m2. So when m1 is greater than m2, then we use this. In case m2 is greater than m1, then we'll have to turn it around. So it will be right. So depending on one that is greater, if m1 is greater, it comes first. If m2 is greater, it comes first. Right. If two lines are parallel, then m1 is equal to m2. Right. If the two lines are parallel, then m1 and m2 are the same. So if they are the same, the numerator here becomes 0. Then the numerator becomes 0. Then tan theta is 0. Then theta is tan inverse of 0. And that is 0. Yes, and that is 0. Right. So when the lines are parallel, that means they have the same gradients, then the angle between them is 0. They don't even meet. If they are perpendicular, then one is the negative reciprocal of the other, right? Then m1 is equal to negative 1 over 2 m2. That means this times this will give you 0. Will give you minus 1. That means m1 plus m2. That means m1 plus m2, right, is equal to minus 1. And then we have plus, right? 1 plus minus 1. That gives us our denominator becoming 0. Once the denominator is 0, that means there is no angle, right? So hey, that means that this one tan. Wow. Right. So whenever you get, that'll be a marked error. So, and then tan 90 is also marked error, right? It's a marked error. It's a marked error, right? So you should know these two scenarios and these two cases. If two lines are parallel, if two lines are perpendicular, so we've done this. The acute angle theta between two lines with gradient m1 and m2 is given by this. And this is what we just saw. So this is the formula we'll memorize. In this case, it is irrelevant which gradient is taken as m1 and m2, right? So we can take any of the gradients as m1 or m2. That means that yes, we can take any of the gradients as m1 and m2, right? So yes. So let's take an example. Our first example, example 1. Find the angle between the lines 2x minus y is equal to 4 and then the other one. So example 1, the lines are 2x minus y is equal to 4 and then x minus y is equal to 3. Find the angle between these two lines. So the formula is tan theta is equal to m1 minus m2 all over 1 plus m1 m2, right? And so we have to find the gradient. So what's m1 from equation 1? What's m from equation 1? If you express that y is equal to mx plus c, that would be right. No, 2x minus 4. If you express this at that form, it would be y is equal to 2x minus 4. And then if we express this one, that would be y is equal to x minus 3. So in m1, m1 is 2, and then m2 is 1, right? Now let's put it in the formula. So what's theta? Theta is equal to tan inverse of 1 over 3, and that is 18.4 degrees. So the answer is 18.4 degrees. That's the angle between those two lines. That means if I draw this line, right? If I draw this line and I draw this line, then the angle in between them is 18.4 degrees. Perfect. So let's take example 2. Right, so you should take note of this. When you are finding the acute angle, right? When you are finding acute angle, whenever you are finding acute angle, you take the absolute of whatever is on the right side of the equal to, right? This side we were taking the whole thing. There was no absolute. We are finding the angle. But if you want the acute angle, or so always when they divide like this, there is an acute angle and then there is one that is not acute, right? So the acute angle is less than 90 and then the other one is greater than 90, right? So if it's 360, so if it's divided into 4, then 2 are the same, so it's divided into 2, then 2 definitely some will be greater than 90, some will be less than 90. So if you want the acute angle, the keyword is acute. So in example 2, you have to find the acute angle. That means you're going to use the absolute value. So let's see, in example 2, find the acute angle between the lines 2x plus y is equal to 4 and y minus 3x plus 7 is equal to 0. We need to find the gradient of both of them. So from equation 1, the first one, y is equal to 4 minus 2x plus 4. That means m1 is equal to minus 2. From the second one, y is equal to 3x plus 7. That means that 3x minus 7 3x minus 7, that means m2 is equal to 3. Now we have m1, we have m2, so we can use the formula now. The absolute of the first one is minus 2 minus 3 over 1 plus their product. So minus 2 minus 3, that's 6. So we have tan theta is equal to, this will give us minus 5, then this will give us minus 5, so we have 1. So theta is equal to 45 degrees. Right. So maybe you might be thinking if you could, change it, right? You can bring this here and then this here, right? Yes, you can swap them because we are finding the absolute, it doesn't really change anything, right? In the end, we get the same answer. So and then because we want the acute angle, always one will be the negative of the other, right? Because m and m, so like one will be the negative of the other. If they will have opposite sides. If one is positive, one is going to be negative. If one is negative, one is going to be positive, right? The slopes will be changed. The slopes will have different signs. So you don't need to worry about it. You can change them, they have the same answer in the end. But when it comes here, you should make sure the greater one comes here and then the smaller one comes here. The highest comes here and the least comes here. Because we'll not be using absolute here, right? If you want the angle, but if you want the acute, you should use absolute, right? Use absolute of 1. That's the one. So absolute is just the value without the sign. If it's negative, you just think of the negative. If it's positive, just think of the positive. It's just the sign, right? In the positive domain, right? That's absolute. Let's try another one. I think we have example 3. Find the acute angle between the line sides. So we have to find the acute angle between these two. And then the formula we're going to use is tan theta is equal to m1 minus m2 over 1 plus m1 m2. The formula we're going to use, so we need to find the gradient of both lines. Equation 1 is already in the form where we can find the gradient. So m1 according to this is just 1 because the coefficient of x is 1. Right, if you don't know how to find gradients, you should check out our previous videos where we found gradients. And then in equation 2, 3y minus x minus 2 is equal to 0. This can be expressed in this form: y is equal to x plus 2 over 3. That means that x over 3 then plus 2 over 3. So m2 is 1 over 3. Now we can find our angle now. Tan theta is equal to m1 is 1 minus m2. So because we're finding acute angle, we're supposed to calculate that. We're supposed to have the absolute value. And then m2 is wait, can m2 be positive too? Yes, m2 is still positive. Minus 1 over 3 all over 1 plus their product. That's 1 over 3. Right, so if you punch this into the calculator, get 0.2. So if you want to find theta, theta is tan inverse of 0.2, and that is 11.3 degrees. Perfect. So we are done.